Today's experiment is density and tour of elements. We already learned in lecture density is mass divided by volume. So first part is density. And we're going to record the density of liquids and solids both. And in liquids, first of all, we'll record the density of water. And then second part, we will record the density of organic liquid. And then we're going to record the density of solids. So in the solids, we're going to record the density of nickel and the metal cylinder. Second part of the experiment is tour of elements. You will be seeing many different elements in the glass container or in the form of cards. Here is an example. This is carbon. So this is the glass container. And some of the elements in the cards, they are expensive elements or dangerous elements. For example, platinum is shown here. So what we need in order to do this experiment, measuring cylinders, 50 milliliter, 10 milliliter, organic liquids, unknowns. I'm going to take B and D, deionized water, nickel metal, and the metal cylinder. And one more thing which I already mentioned before, the different elements in the glass bottles or in the card form. We cannot dispose the organic liquids in the sink. So we have a special container to dispose them, and this is the container I'm going to use to dispose of my used organic liquids B and D. So let's start with part A, density of liquids, and within that let's do the measurements for water. So I'm going to record the mass of 50 milliliter graduated cylinder. I just stir it, so now nothing is on the balance pan, which will add to the weight or the mass of the graduated cylinder. I just added 15 to 20 milliliters of DI water into the weighed 50 milliliter graduated cylinder, and that's the reading. So you can note down the reading. And this is going to be at the eye level. So you can note it down. Now I'm going to take the mass of the graduated cylinder and water, same volume of water. So you are going to determine the mass of water by weighing by difference. And then you will calculate the density of water using the formula mass divided by volume. So we already determined the mass, we already determined the volume, and then you can apply in the formula to get the density. Make sure your significant digits, all right? And then it's always good to have the calculations written there. This page will not be graded, right? This is for you, but let's see if you made any mistake. So you can go back and see what you did, and you can correct yourself. Now, second time I added about, like 35 milliliters of water. I did not weigh the measuring cylinder again because I'm going to use the same measuring cylinder, so you can note down the reading for the second time for the volume of water. Here also you are going to determine the density of water the way you did in the previous step. And again, show your calculations. So let's start now the recording the measurements for density for the organic liquids. Mass of 10 milliliter graduated cylinder. Now I'm going to discard the unknown liquid B into the waste container. Working with the unknown liquids B and D, which are organic. So this is not good to inhale, and they are flammable liquids. So it's just make sure that you are working in the hood when you are dealing with those liquids. So I've already added between 7 to 9 recording the mass of unknown liquid B in the graduated cylinder. Now I'm going to dispose of unknown liquid B into the waste container. Okay, now the time is to record the measurements for unknown liquid D. Well, we already had unknown liquid B, right? So this measuring cylinder does have very slight amount of unknown liquid B, which might affect the density of D. So what I will do, I will add few drops of unknown liquid D. And then I will condition it with this liquid. And I'm going to dispose of this into the waste container. So now I added between 7 to 9 milliliters of D into the measuring cylinder. You can note down the volume reading. Mass of unknown liquid D and the measuring cylinder. So I'm going to dispose of now my unknown liquid D into the waste container. Now you're going to fill the data for the organic liquids density into this table. So volume, mass of liquid plus cylinder. Cylinder means graduated cylinder. Mass of liquid, you're gonna calculate by difference, and then the density of liquid. Again, you know, it's always good to show the calculations. Okay, so now we're gonna work on the density of solid. So first I'm gonna work on the density of the nickel. So I'm gonna record the mass of 50 milliliter beaker. Now I'm going to record the mass of 50 milliliter beaker and the nickel spheres. Make sure you're going to add the nickel spheres into the beaker very slowly because they are pretty heavy and it might break the bottom of the beaker. Now I added about 20 milliliters of DI water into the measuring cylinder. You can note down the reading. Okay, now I'm going to add those weighed nickel spheres into the graduated cylinder, which has about 20 milliliters of water in it. And make sure you are going to add these spheres very slowly. You're going to roll them down. Right? Do not add from the top. It will add from the top. It might break the bottom of the cylinder. And likewise, I'm going to add all the other spheres into the measuring cylinder. So this is the reading of the water after adding the nickel spheres. You can note down the reading of the displaced water now. When you are going to take out the nickel spheres from the measuring cylinder, make sure you have your hand in front of the measuring cylinder in order to secure the nickel spheres. Otherwise, sometimes it might roll down and goes into the sink and we might lose them. And you can put it in this tray to save them. So here you are going to do the calculations for the density of nickel. So mass of the beaker, mass of the nickel plus beaker, calculate mass of nickel by difference, volume of water. All right, and then here when you will do the volume of nickel by displacement, you're going to read it in milliliters, right? But then you are going to convert into centimeter cube. We learned in the lecture 1 milliliter equals to 1 cubic centimeter. The reason is because we always give the density of solids in grams per cubic centimeter, and density of liquids is recorded in grams per milliliter. All right, now we're going to start the working on the density measurements for metal cylinder. So now I have added 25 milliliters of DI water into the measuring cylinder. You can note down the reading. So here I'm going to record the mass of metal cylinder C. So now I have here a metal cylinder. The number is C. I'm gonna roll it down very slowly into the measuring cylinder. And you can record the volume displaced. So now we are going to work on tour of elements, right? So this is carbon. You are going to actually give the information about this element into the periodic table. It's basically a worksheet of the periodic table is given here in your lab manual. So this is the place for carbon, right? So what you are going to record. Let's go back here. And you're going to record atomic number, which is 6. Carbon, it's the symbol. Name, carbon, which is the name of the element. And what state is that? This is actually solid, right? And then what is the color? Black. So basically, these are the things basically you are going to mention in the periodic table, which is right there at this place. Okay, now when you would write the information about the elements, make sure you are going to mention the group numbers, either A and B part, right? Or you are going to mention the numbers 1 to 18. So whichever convention of the periodic table you would choose. So the column should be basically mentioned. So I'm going to show you different elements here. Not all of the elements which are present in the periodic table, they are displayed here. So if they are gases which are not displayed here, you are going to write G, right? Mostly the noble gases you will find, which you're going to write G, and liquid and L for liquids. And you can use different color pencils for that. If you do not find any solid here displayed, so you are not going to write S for that. So just leave them blank. Carbon, cobalt, calcium, titanium, palladium, chromium, indium, zinc, copper, silicon, arsenic, tungsten, molybdenum, oxygen, nitrogen, bismuth, tin, iron, manganese, nickel, lead, cadmium, antimony, aluminum, iodine, zirconium, sulfur, silver, magnesium, germanium, lead, oops, sorry, mercury, sodium. These are all basically dangerous. Mercury, sodium, right? Carbon, I mean in the form of diamond. So this is very expensive. Lanthanum, lithium, uranium, gold, and platinum. So that's all about in experiment number 3, density and tour of elements. This is basically the report. Make sure you are going to fill these 3 blank spaces. When using the balance, record the mass to the dashed place, right? So you're gonna check the recordings and see that how many decimal places are in there. Similarly, you are going to see the 50 milliliter graduated cylinder, and then you are going to record the decimal place here, and so as for 10 milliliter graduated cylinder. And then you are going to show all the values here. Make sure you show the calculations, and continue this here on this page, and then you are going to answer this question. That is very important. And then it's remaining here, and we already discussed about this part, which is the worksheet of the periodic table. You're gonna fill it.